Okay, so we're going to talk about writing a linear equation from a table. So there is a difference between writing a linear equation from a table and writing one from a graph. However, the equation is the same. So our equation that we always talk through is y equals mx plus b, where m is your slope and b is your y-intercept. So that isn't anything different than from a graph. Basically, the way that you're going to find it, the slope, we're going to find it the same way, just with numbers instead of a picture. And the y-intercept is pretty simple as well. So I'm going to go ahead and delete this m and this b, and we're going to put our little blanks back in there. And as we find our information, we're just going to fill in the blank of our linear equation. So hopefully you remember the formula for finding the slope of a line is always delta y over delta x. And I tell my kiddos, no matter if you're finding it from a table, if you're finding it from a graph, you always have to write the formula. So that's the very first thing that you should be doing. And remember, delta is just the change. So on a graph, we can see how much it changed by looking up and down. But if we're looking at our y values right here, all we have to do is figure out how much did it change from 0 to 6. So from 0 to 6, it went up, so it increased. And from 0 to 6, that's pretty easy to see, it went up by 6. So our delta y in this case would be 6. And now we would do the same thing. We would just look at our x values this time. If I was over on this side of the table, I have to find delta x from the same section. I could not, okay, for instance, if I find delta y over here, I would not be able to come down here and find delta x. Some tables are a little bit tricky in the fact that they try to trick you. So that's why if you're going to find it, you got to find it from these 2 points all the way through. So let's do that. Between -2 and -1, that increased by 1. It's not always going to increase by 1, so don't get tricked there. So for delta x, we're going to put a positive 1. And then 6 divided by 1 is actually just the whole number 6. Okay, so we're going to put that in our slope. Again, just a reminder, you could do this from anywhere in the table. So let's say I wanted to find delta y here, then I would find delta x here, and you would notice it would actually be the same. So it'd be 6 over 1. So you can definitely use any piece of your table. You just need to make sure you're using the same section. Okay, so the y-intercept on our graph, it's really easy to find because you just find the y-axis. So on a table, it's always where x equals 0. So let's see if we have a nice spot where x equals 0 here. Sometimes they give us 1 and sometimes they don't. So this is x is -2 and y is 0. That's not what we want. We want where x is 0. This is x is -1 and y is 6, so that's not going to be our y-intercept. This is x is 0, y is 12. So our y-intercept would just plug in and be 12. All right, so let's do this next example. Same situation. The very first thing we're going to do, we're going to write delta y over delta x to find the slope. And I'm going to find it from a different part of the table this time just to kind of prove that it works. So from 10 to 15, let's talk through. It increased, which means it's going to be positive, and it increased by 5. Now, if you can't find that, if maybe the numbers aren't nice or friendly, the way to find the change is to subtract. So notice, again, if the numbers are kind of yucky, you can come over and do some scratch work and you can find the change in y or x. So delta y was 5. Again, I'm going to go to the same spot in my table, and x is increasing by 2 this time. So that's going to be a positive 2. Now we could change 5 over 2 to be 2.5. However, I think in this case it's going to be a little bit friendlier if we just leave it. So let's do y equals blank x plus blank. And remember, m is our slope and b is our y-intercept. So we can go ahead and plug in positive 5/2 to that. And now let's talk about this y-intercept because it's supposed to be where x equals 0. So let's take a look at our table, because this is 2, this is 4, this is 6, this is 8. So there seems to be a little bit of a problem with my y-intercept. I can't quite find it just by looking. But what we can do is we may have to work backwards a little bit. So let's just make this really nice and clean so we can see what's going on here. This table is going up by 2's every time. So this is going from 2, it's adding 2 and going to 4. And then it's adding 2 and going to 6. And then it's adding 2 and going to 8. So I wonder if we go backwards, instead of adding 2, if we go backwards, we would be at 0. So that would be where we would need to find our y-intercept. So if we can find the y value over here, so let's say we went from 15 to 10, from 10 to 5. So I'm guessing you already can see it's subtracting 5. If we're going backwards, it's subtracting 5 each time. So 5 minus 5 is going to be 0. So this actually would be a way that we could find our y-intercept. So we just worked backwards a little bit, and it would be 0, which that means this one would cross through the origin. Again, if you can't find your y-intercept, be creative and maybe work backwards a little bit, okay? Good luck!